Hi, I'm Sarah. I'm here to talk about the FetchIt Mobile Manipulation Challenge. So that was a competition we put on this year at ICRA. That was a project I did with a bunch of people, Niharika Aurora, Carl Saldana, Alex Moriarty, and a ton of other people. So we held the competition this year in May at ICRA 2019 in Montreal. And the first place prize was a Fetch mobile manipulator robot. So basically, you can win a Fetch. And so one kind of big question here is like, why would we have another robotics competition? And I guess the main answer is that we're really interested in industrial applications like kit filling, machine tending, bin picking, and a lot of existing competitions either didn't really cover that kind of subject matter or also were designed maybe for other types of robots, or the scale of the task wasn't quite right for the Fetch. So even though it was technically eligible for those competitions, it wasn't a great fit. So we decided to have our own competition. So how do you actually win a Fetch? Basically the goal of the competition was to assemble and deliver as many completed kits as possible in 45 minutes. And so a completed kit basically consists of 6 3D printed parts that you can see on the slide. So 2 bolts, a large gear, a small gear, a gearbox top, and a gearbox bottom, and placed in the correct compartments of this divided tote. And all the models for the parts and like the totes and everything else are on GitHub. And then also, I think in a couple slides, there's a link to the complete rulebook, which will also show where you can buy some of the like off-the-shelf parts if you wanted to try this yourself. So in order to assemble a kit, the robot has to go around to different stations in a 10-foot by 10-foot arena, pick up parts, simulate a machining task, place parts in the kit, and then place the kit at the drop-off location and trigger a camera to inspect it and make sure the kit is complete. So this is basically the layout of the actual arena, Fetch included for scale, in Montreal. So it's a 10-foot by 10-foot arena. You can see all of the stations labeled there, and it doesn't really matter within the rules. You can visit the stations in any order. I'm gonna quickly, you'll see in the video coming up kind of an example of how to put together a kit, but I'm gonna dig into a little bit this like simulated machining task here, because I think that's probably the part that will be the least clear in the video, I think. So circled in blue is the shunk machine and the gear pick station. So you can see on the surface of the workstation there's the large and small gears, so that's where the robot will obtain those parts. And before putting the large gear into the kit, the robot has to simulate machining it, which involves inserting the large gear into the jaws of the chuck on the machine. So there's kind of a close-up. And the chuck jaws are it's 3.5 centimeters in diameter, and the shaft of the gear is 3 centimeters in diameter at its widest point, and it tapers to about 2 centimeters at the tip for easier insertion. And basically, the robot inserts the gear into the chuck and then uses an action lib interface to trigger the chuck jaws to close. And then once the part is enclosed there, the simulated machining task will basically take 2 minutes, and then after the 2 minutes are up, the robot can retrieve the part through the same action lib interface. So yeah, so there's a closer up, even more view of that. But another Another kind of caveat, I guess, or something that we decided for the competition that we ran this year was we guaranteed for teams that the parts would not be touching. So this is especially important, I think, for the bin picking task because it's not really a true bin pick. It's like we did say the parts won't be overlapping, so they'll be, more easily separable and segmentable. And what you see here is a pretty typical layout for the way that parts would be laid out on the surfaces. So most of the teams that participated actually had access to a Fetch robot already in their labs at their universities. So they use that a lot to practice for the competition. Also, you could make use of a gazebo simulation. Thank you to the construct who put that together for us. But as an added thing, we also provided a remote arena that participants could VPN into the robot and then try out their code, build their code, run it in this arena that we set up in San Jose. So the overhead, there are 4 overhead IP cameras. So you can see kind of the view from one of the cameras above the shrunk machine there. And that's like the other view is the entire 10 by 10 arena in our building. And so we ended up having to do VPN access because we initially were thinking of just exposing like a couple of ports to the outside world, but Ross kind of wants to use all the ports ever, so we ended up using a VPN. But I think it worked out pretty well. Okay, so I'm not going to go too deeply, I think, into the scoring for this. If you have any questions about scoring, the full rule book is linked on the bottom. And then also you can ask me or Naharka or whoever after the competition, or sorry, after the talk in our booth. But 2 things I guess I want to highlight are that a full delivered kit is worth 7 points. But a partial kit is worth 0 points. So there's no partial points at all. And so obviously like a kind of side effect of this is that you could get 99% of the way to delivering a kit, and if you're missing an item or something, you don't get any part points for that. And this was basically just to prevent kind of point farming. We didn't want teams to be able to avoid doing difficult tasks and just try to repetitively do easier tasks to gain a bunch of points. This scoring system was pretty well received by all of the teams though. I think nobody really likes participating in something that allows you to farm points like that. Another kind of side effect of that basically though is that the total point scores that teams achieved are not like always a great reflection of their performance on the task, because like you could end up with 0 points even if you got 99% of the way through a delivery. So for that reason, we haven't and we're not going to release the full point totals for each team. We will release the standings, but we just don't think that it's very representative. So, the results. So in May in Montreal, Georgia Tech got first place. So they won a Fetch mobile manipulator research robot. So that was Sonia Chernova's lab at Georgia Tech. They also got some sponsor prizes. So both the first place and the second place team, which was UMass Lowell, got sponsor prizes from the other co-sponsors of the event, Shunk and SICK. So here I'm going to show you guys a quick video of just like the robot completing a full kit. I feel like this is probably the moment we're all most waiting for. So this is just an overhead view of where things are in the arena, because the viewpoint is changed up a bit from my previous slide, but I think it'll be okay. I think we can keep track. So before I start it, you can see at on the base of the robot, Georgia Tech actually chose to put like a little mount point that the kit can slot into on the base. And this is because the fetch robot really only has one arm. And so if you want to be carrying the kit around to different stations, you have to set it down somewhere. And so that was a strategy that worked out well for them. But another strategy that teams used was just filling the kit in place at the kit station and then picking it up at the end. So here I'm going to start this. Okay, and this is sped up 12 times, by the way. So yeah, first they picked up the kit, they put it on the base, and they're going to do the gear insertion task first. And we'll get a closer look at their gear insertion strategy later. But then they're going to grab the small gear, and this is while they're waiting for that 2 minutes for their part to be machined. They're going around doing some other stuff. So they come back and they get their large gear, and then they're going to go so they need 2 screws from this bin, and I think in some ways this might have actually been the weakest part of the task for them. Because they sometimes had a hard time telling if they actually got a screw. And they're going to drop it in there, and that's it. It's looping. So that was a delivery that would have been worth 7 points plus a bonus point for delivering the kit within the square that you see over there and triggering the camera to inspect it. Okay, now for more fun, I put some more fun videos here. And I called it manipulation strategies, but actually it's just because I think they're fun. So specifically the gear insertion task is kind of interesting because there are kind of 2 different approaches to this task, I think. Like some people chose to visually triangulate the chuck very specifically, very accurately. So UML did that, and they did kind of like a one-shot insertion while after like doing a pretty precise triangulation. But Georgia Tech chose to kind of only generally locate the chuck and then to physically triangulate the position. The middle video I just included because I like it. And the last one is kind of an interesting strategy that a couple of teams realized, which is that the torso lift lower joint is actually one of the faster moving joints on the robot. And it also, like, if you only need to translate the end effector up or down, then you don't have to plan if you like make an arm plan if you just use the torso joint. So a lot of teams took advantage of that. It actually allows you to do a lot less manipulation if you just decide you want to drive and lift and lower. So in terms of software tools, we enforced using ROS Melodic. Probably the best thing about this was that it forced us to release things for ROS Melodic for the fetch. Most of the teams use Gazebo, and again, I want to thank the Construct for helping provide the web-based simulation for us. And you can find all of the simulation stuff at our Fetch Gazebo repo, in the FetchIt, mostly in the FetchIt competition folder. I think almost all the teams use MoveIt in some capacity for manipulation, not necessarily for all of their manipulation, but at least for something. And as a plug, we are hosting World Move It Day in November in the Bay Area. So if you're going to be in the area, come visit us at Fetch. We also sort of encouraged people to use Docker because especially for the remote sessions, that was a lot easier to download a Docker image onto the robot. Oh yeah, we required all the teams to open source the code for their solutions, so you can look up the winning solutions at the links at the bottom of the slide. So lessons learned, a lot of lessons. One of the biggest limitations, I think, of the competition was that it was very difficult for teams who didn't already own a robot to participate. And I think we knew that was going to be a limitation going in, but we were still a bit disappointed that we didn't really have the resources to support those teams better. So that's definitely something we'd like to improve. We really want to improve our simulation. Gazebo 9 has exposed some weaknesses in our gazebo model. Specifically, I think the way that we modeled our base. In Gazebo 9, it tends to rock back and forth sometimes, and so you tend to get mislocalized a lot, as you can see in the GIF. So we got to work on that. And then better remote access, just generally better internet would be something that I imagine people experience a lot, but you could stream point clouds and stuff over the VPN, but sometimes it would be too high bandwidth for our system or for the competitors' systems, potentially like their internet connection. So we did also encourage them to record ROS bags and look at the data offline. And at the venue, definitely better internet. I'm not sure we have as much control over that as we do in our building, but there's definitely a pain to have to walk around with a network leash with the robot all the time. So for FetchIt 2020, just briefly, we're still kind of narrowing down locations, so we're hoping to get that information out as soon as possible, but some potential locations would be IROS next year or ICRA next year. We are considering using off-the-shelf items next year potentially instead of the 3D printed parts, but we would keep the scale and the number of parts probably essentially the same. I think we're looking to have a greater focus on kitting, especially to make the kit more realistic. So instead of just dropping a part into the kit, it might be a tighter fit. And obviously real bin picking would be good. And I think a lot of the teams are actually enthusiastic about these changes. And a big thing I mentioned before, just improving the experience for people who don't already have a robot. So we're considering a lot of options for that. We don't really have the resources to run two separate competitions, like one simulation and one physical competition, but we're trying to consider other ways, I guess, that we can help people who don't already have a robot win, because we don't want it to be a competition where only people who already own robots win every year. So, in summary, this is not a talk about buying a Fetch. This is a talk about how we gave away a Fetch. We want to give away another Fetch, so don't buy a Fetch, just participate in the competition and win a Fetch. Okay, thank you. And I should thank our co-sponsors for FetchIt, which were Shunk, SICK, E&M, and the Construct and Fetch Robotics.
All right, we've got time for a couple of questions. Did you want? Yeah.
Thank you. Really interesting talk. I would like to know on what timeline you accepted the teams and what you would do differently if you hosted the whole thing again.
So I think we announced it either right at the end of last year or the beginning of this year. I think it was early January. And then the competition was in May, so it was a very short time frame. Yeah. And I'm actually shocked that anyone agreed to do this. No, I shouldn't say that. But sorry. But yeah, and then we did a qualification where teams kind of submitted a resume type thing to us, and I think we finished the qualification by the early sign-up date for ICRA, so it was mid-February. Because we wanted people to be able to do the early bird registration if they wanted to go to the conference.
Hey, nice. This is really cool. For the remote access, is there enough CPU capacity for them? They just SSH to the robot and do everything there. There's not another computer on the local network that they would record ROS bags to. They do everything on the robot.
Yeah, they did everything on the robot. We did put a 1 terabyte hard drive in the robot, which it doesn't normally ship with, but in terms of like CPU, it was identical. We did get questions about like offboard compute and whether we would allow that, but especially since like as a business, we try not to rely on like Wi-Fi or anything else. Yeah, we didn't allow that.
Okay, so the main limitations was the network bandwidth.
Yeah, the network bandwidth of like trying to stream a point cloud or like the camera data even. Like we had 4 ceiling mounted cameras and it ended up being that you could basically only look at one at a time.
Okay, thanks.
So we've done a number of usually simulation-based competitions, and one of the challenges that I found we always have is you're basically designing a game, and it's hard to tune the difficulty and make sure that it's challenging enough but also feasible. Did you guys actually solve the task yourself to convince yourselves that it was doable?
Sort of. We had an intern who worked on like similar type tasks and stuff. Yeah, we did have a lot of arguments about making it harder or easier. And I think we did hit a good difficulty for the competition this year because out of the teams that participated, only 2 teams were able to actually make qualifying runs in order to like say place. So that's why we have a first place team and a second place team, and all the other teams were not able to make a qualifying run. So I think we were lucky to hit that difficulty decently.
All right, well, thank you very much.